Assalamu alaikum, dear students. This is Shamshad Ali, Department of Technology, Sarad University. Today we are going to learn about the earth pressure theories, part 2. In the previous lecture we have learned about the ranking theory, both the active and the passive. And in this lecture we will learn about the Coulombs theory of the lateral earth pressure. This is our week 10 and our lecture 10, 5th semester, 3rd year, BSc Civil Engineering Technology. You can access this lecture at portal.shu.edu.pk. So let's begin now today's lecture. Coulombs theory. Coulombs theory for soils with C is equal to 0 mean the cohesionless soil, and angle of internal friction will be greater than 0. Coulombs theory differs from Rankine in that the resultant of the normal in shear forces acting on the wall is inclined at an angle theta into W, perpendicular to the wall, where tangent of the theta W is the coefficient of friction between the wall and the soil, as shown in the figure 1. This is a more realistic model and thus produce more precise value of the active earth pressure. Here you can see that this is basically the resultant of the lateral earth pressure, and this is basically the shear. Rankine ignored this friction between the backfill material and the wall surface. This is the beta, represent the inclination of the backfill soil. This is basically the alpha. Alpha represents the angle of the wall. This is almost 2 degree, 3 degree, 4 degree, 5 degree, just like that. And this is basically the theta W. Theta W will be the angle between the shear forces acting on the wall and the horizontal forces. So the angle between them will represent the theta W. Coulomb represents the equation for the lateral earth pressure, for the active earth pressure. Pa divided by G by B is equal to gamma into S square, K into A, cos of the theta W divided by 2. While when you calculate the shear, the formula is here, P into A divided by B is equal to gamma into H square, K into sine of the theta W divided by 2. Just here we can see that here is the cos of the theta W and here is the sine of the theta W. Now if you want to calculate the coefficient of active earth pressure in the Coulombs theory, here the equation is quite lengthy as compared to the Rankine theories. Cos square theta minus alpha divided by cos square alpha, cos of the theta W plus alpha, 1 plus sine theta plus theta W under the root sine theta minus beta divided by cos theta W plus alpha, cos of the alpha minus beta, whole under the root and the whole square. So this will give you the coefficient of the active earth pressure, where the sigma represent the normal pressure imparted on retaining wall from the soil, tau represent the shear stresses imparted on retaining wall from the soil, P divided by 9 normal forces between soil and wall, permanent length of the wall. Permanent length will be 1 meter or 1 feet. Shear force between soil and wall, permanent length of the wall. B is equal to unit length of the wall, usually 1 feet or 1 meter. Active coefficient of lateral pressure, vertical effective stresses, inclination of the wall from vertical, inclination of ground surface above the wall, and wall-soil interface friction index. Above equation is valid only for beta less than or equal to theta. When designing concrete or masonry wall, it is common practice to use theta into W 0.67 of the theta. You will take the 0.67 of the angle of internal friction, effective. Steel walls have less sliding friction, perhaps on the order of theta W is equal to 0.33 of the theta. If the wall is made up of concrete or masonry wall, then you will take the theta W is equal to 0.67 of the theta, angle of internal friction. While if the wall is being constructed with steel, then there is less sliding friction, so you will take the theta W 0.33 of the theta. Coulomb did not develop a formula for passive work pressure. Here, focus on this, that Coulomb did not represent any formula or any equation for the passive work pressure, just because in that era of the Coulomb, there were no concept of the other type of the structure, just like the cantilever retaining wall and the concrete wall. They were just only the gravity wall, made up of masonry, stone masonry, brick masonry. Okay, so he did not represent the formula or equation for the passive work pressure, although others have used his theory to do so. However, the addition of wall friction can substantially increase the computed passive pressure, possibly to value that are too high. Therefore, engineers normally neglect wall friction and passive pressure computation, theta W is equal to 0, and use Rankine method to compute passive pressure. Previous topics. Now we are going to solve an example. Here we have a structure. Using Coulomb method, compute the active pressure acting on the reinforced concrete retaining wall shown in figure 2. This is a retaining wall. Height is equal to 5.60 meter. Height. The angle will give you the one in vertical, 2 in horizontal. So you will take this at the tangent inverse of the 1 divided by 2. Here we have the alpha. Alpha is equal to 2 degree. The inclination of the wall is 2 degree. If you made this wall is just like that, then the inclination of the wall is equal to 2 degree. Here the cohesion is equal to 0, cohesionless soil, and theta is equal to 32 degree, and unit weight of the soil is equal to 19.8 kilonewton per meter cube. So let's begin the solution. First you have to calculate the beta. So beta, the tangent inverse of the 1 divided by 2, will give you the answer, which is 27 degree. Theta into W is equal to 0.67 of the angle of internal friction. As we have learned that if the wall is made up of the masonry or the concrete, then you should take the 0.67 of the theta, which is equal to 0.67 of the 32 degree is equal to 21 degree. So theta W here is the 21 degree. Coefficient of lateral earth pressure, this is the formula. When you put the values, it will give you the answer of 0.491. Mean it is in the range of 0.2 to 0.9. So your calculation is okay. Now moving on, calculating the active earth pressure acting on the wall, unit length of the wall. So here is the formula. When you put the values and calculate, 142 kilonewton per meter as the active earth pressure acting on the wall. Share, you have the formula. When you put the values, the answer is 52 kilonewton per meter. Lateral earth pressure in soil with C greater or equal to 0 and theta greater than or equal to 0 mean for the cohesive soil. Almost the sandy or clay and just type of soil. Rankine did not address lateral earth pressure in soil with cohesion greater than 0. Coulomb represents the both cohesive soil and cohesionless soil, but Rankine did not address the cohesive soil, and Coulomb did not address passive pressure. However, later investigators developed complete formulas for cohesive soil. Bell 1915 was among those who contributed. Theoretical behavior of the soil. Soil with cohesion can stand vertically to a height of no more than the critical height. You have seen that if there is some kind of muddy type of the soil, it can restrain its height up to some height. That is the critical height. So soil have cohesion can stand up to some height due to the cohesive forces among the soil particles. So if you want to calculate the critical height for a wall which have cohesion greater than 0, the formula is 2 into C, C mean cohesion, gamma unit weight of the soil, and K coefficient of active earth pressure. It will give you the answer. In other words, at H less than Hc, the earth will stand vertically without a wall. Mean at the height of the, if you want to construct a retaining wall on the soil which have cohesion greater than 0, then first you have to calculate the critical height. For example, if there is a height of 10 meter, but the critical height is 4 meter, then the soil can stand up to 6 meter without any support, without any retaining wall. This is basically the reason. In practice, we will apply some factor of safety to H, perhaps 1.2 to 2, before deciding not to build a wall. But here you can apply the factor of safety. For example, if the total height is 10 meter and the critical height is 3 meter, then the soil can stand up to 7 meter. But when you multiply 1.5, 1.2, so then it will reduce the height up just for the factor of safety. Engineers also would want to consider the potential for surface erosion and other modes of failure. If there is some kind of the water and during the rain, the water comes to the soil, so then it may fail. If H greater than Hc, the theoretical pressure distribution is as shown in the figure. If the H is greater than, earth pressure equation then you have to calculate earth pressure by this. This is just represent the critical height. This represent the critical height. These formulas upon are incorrectly stated without the 2c squared divided by gain term. This term must be present to account for the lack of tensile forces, flood retention cracks between the wall and the soil at the depth shallower limits. Flood retention cracks, this phenomena can cause in the expensive soil. At the presence of the water, it becomes expand, while when the water is drained after some time, the soil becomes shrink. This is the flood retention crack. There are cracks produced in the at the wall, at the adjacent of the wall, backfill and adjacent to the wall. So these are termed as the flood retention cracks. The Rankine equation for passive condition is in soil with cohesion or SPA. These are the Rankine equation for passive condition. The theoretical shape of the passive pressure distribution is shown in figure 4. This is basically theoretical pressure. actual behavior. And the theoretical behavior may be approximately correct for sandy soil that develop cohesive strain from cementing agents such as calcium carbonate or iron oxide. However, it is not a good indicator of lateral pressure in clays and may produce conservative design. This discrepancy occurs because the earth pressure theories do not consider the following aspects of the clay behavior. Clay have the creep behavior. When the shear stress in a clay soil are larger percentage of the shear strain, a phenomena known as creep can occur. The soil slowly shear and never reach complete equilibrium unless the shear stresses become sufficiently small. When this happens behind a retaining wall, the failure wedge slowly moves towards the wall, so it is impossible to maintain the active condition, which demands higher shear stress for long periods. Therefore, design cantilever wall backfill with clay using something higher than the active pressure. Expansion is, as we already discussed this terminology, the soil expands and the retaining wall moves outward. The soil shrinks and moves slightly downhill, thus remaining in intimate contact with the wall. Crack forms, fluid retention cracks, loose debris falls into the cracks, preventing them from closing. The soil expands again and move the wall further out. Poor drainage, the main factor. Clays have a low hydraulic conductivity and thus obstruct drainage. Therefore, groundwater may become trapped behind the wall, producing hydrostatic pressure on the retaining wall, and this causes the increase in the active pressure, also in the passive pressure. So this is it for today's. Hope you will learn something about. Next class, inshallah, we will learn about the types of retaining wall, analysis of earth retaining structure. Which type of earth retaining structure could be analyzed and what type of analysis has been done on the earth retaining structure. So thank you so much. If you have any query regarding today's lecture, you will let me on the portal.su.edu.pt. So take care.